Okay, so solving multi-step equations. Kylie, we did do about half of our notes, maybe a little bit more than half of our notes last week. So this is going to be the second half of the notes. So this should be what we pulled out of the box. All right, so the first part last week, remember, was just combining like terms. So just a quick review. Make sure that when you're combining like terms that they match identically. So the variables have to be the same all the way across the board. So if one of these were n and the other one was n squared, we cannot combine those. They're not like terms. In this case, what is 2n minus 3n? Negative n. There's no reason to put in negative 1n. So let's jump ahead into our foldable as a quick review. So when we're solving multi-step equations, step number 1 is to clear the equation of fractions and decimals. So we're going to practice a couple more of those types of questions today, getting rid of those fractions and decimals. If there are no fractions and decimals, then you can certainly proceed with fractions and decimals. There's nothing wrong with that, but you can clear it as well. If there's parentheses, you have to get rid of the parentheses before you can start getting the variable on the side by itself. So you have to do something to undo it. Then you combine like terms, and then you're going to continue with the two-step equations, undo addition and subtraction, and finally undo multiplication or division. Okay? So let's do a quick question like we did all of these, is that right? In the foldable? Okay, so let's go to a question like this as review. 4n minus 2n equals 22. We have no fractions or decimals to clear. We have no distributive property, no parentheses to get rid of, so we simply have to just combine like terms. What's 4n minus 2n? 2n. Bring down the 22, undo multiplication, and is going to equal 11. So if I had to justify each step here, in justifying each step, the first thing we would have done was combine like terms for justification of our steps, division property of equality, and then divide. Over here, 6 times the quantity x plus 1. We have no fractions or decimals to clear, but we need to do the distributive property to get rid of these parentheses. What is 6 times x? And what's 6 times positive 1? So now we're back to a two-step equation. What are we going to do to get x on a side by itself? 6x is going to equal 4. Next, divide by 6. X is going to equal, you don't need to change this to anything but a fraction in lowest terms. Do you see how it's already a fraction? We just need to reduce. So what can 4 and 6 both be divided by? 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. So just leave it as x equals 2/3. Solve 3a plus 6 plus a equals 90. What's the first thing we should do here? Combine like terms. Make sure you are looking at the sign that is coming in front. What is 3a plus a? Now what? Four a equals. Next. Divide by 4. A is going to equal 21. Okay, how about the next example? What are we going to do here? Distributive property. 2 times x. 2 times negative 3. Next. 8 plus 6. Next. X is going to equal? Again, you should be able to put your answer into every single one of these to see if you got it correct. So fractions. Get a common denominator to begin with. What would be the common denominator for 2 and 5?
10.
Okay. What are we going to take times 2 to get 10? 5. So what is 3 times x times 5? 15x. What are we doing to 5 to get 10? So 2 times x would be? Now, how can we clear that equation of fractions? Multiply by your denominator. We can take every single one of these numbers and make them 10 times bigger. So if I multiply fractions, I'd put 10 over 1, right? Well, my cross diagonals would both become 1 if we did that. So it's just going to leave 15x in that first one. In the second one, it's just going to leave the 2x. There is no 1, or if I made both of these a fraction and put them over 1, I'd be multiplying 10 times 17 and 1 times 1. 10 times 17 is 170. So we just made all of the fractions 10 times larger, which essentially leaves behind their numerators. So now, what's 15x plus 2x? Equals 170. Next. Divide by 17. X is going to equal 10. Okay, so the next example with the fractions in there. M over 6 minus 7 equals 2/3. Again, make sure you have a common denominator. What denominator should we use? Move my subtraction sign up. So there's no reason to change that first fraction, correct? It's already got the denominator of 6. What are we taking times 3 to get 6? 2 times 2 would be? Okay, so now what?
Multiply both sides by 6.
Multiply every term times 6. We have to make all of our numbers 6 times larger than what they currently are. I can't just do it to 2 of them and not to the third one. Okay, all of the terms have to be 6 times larger. So now, these are going to cancel, leaving my m. 6 times negative 7? Negative 42. Oops, and 4 6 times 6, again, the 6's are going to cancel. So we have just the 4. Now what? M is going to equal 46. Does anybody want to see any more of those fractions? We had one where we distributed this one in our notes last week. Did we finish this one?
No.
We did not? Okay, let's go back and do that one then. I couldn't remember if we had just gotten to that and the bell rang or we started it. What was the scenario? We had just started it and the bell rang, is that right? Okay, so this one is a little bit different. So I'm just going to rewrite it for my own sake, so it's a little bit larger and I can keep track of where I'm at in the question. You can distribute 1/4 if you want. Okay, you could even change 1/4 to 0.25 if you wanted to, and to distribute. If you want to get rid of the fraction, the only number on the left-hand side that's going to change is the fraction. Okay, I'm not going to change anything in the parentheses. What's in the parentheses is being protected right now, Because I'm going to make this number 4 times larger, and I can make the other side 4 times larger. Okay? So instead of finding a fourth of these are going to cancel. It's just going to leave 1 times g minus 6, or g minus 16, and 7 times 4 is 28. Okay, so when you have the distributive property and it's a fraction that's being distributed, you're only getting rid of the fraction inside or outside of the parentheses. Everything else is considered to be protected. So instead of finding a fourth of it, now you're just taking and distributing a 1, which of course is just g minus 16 equals 28. So now if you add 16 each side, g will equal, I'm sorry?
44.
44. You're not always going to get a whole number. You could get a mixed number there. Do you want to see another question like that? Let's insert a new slide here. Let's say that we were going to do 2/3 times 6g plus 3 equals, let's say 12, okay? Find some place to put this question in your notes, whether it's a blank space inside your foldable or white space, someplace where you can reference this again. So we want to get rid of that fraction. What is the denominator of that fraction? 3. So we're going to multiply the fraction outside times 3 and the whole number on the other side times 3. So the denominator is going to cancel. Do you see how we're going to make, instead of finding 2/3 of everything inside the parentheses, we're going to double everything inside parentheses? And 12 times 3 is going to become 36. Now we're back to a regular type of question. So what would we do? 2 times 6g is 2 times 3 equals 36. Now what? 12g is going to equal 30. Next. 12 goes into 30 how many times? 2. 2 times 12 is 24. 30 minus 24 over. So now change that. 6 is going to equal 2 and a half. So you may end up with fraction again in your answer when it's all said and done. Do you understand the difference between if we have the distributive property, how to get rid of the fraction, and how to get rid of the fraction when there is no distributive property? Distributive property, only the fraction in front gets changed, and the answer on the other side. Otherwise, get common denominators and multiply every term times that number. Okay? Let's go to the decimals. So if I want to get rid of decimals, you need to multiply by 10, 100, 1,000, 10,000, whatever the case might be, to get rid of those decimals. So I notice that there's 1 number behind the decimal here, 2 behind the decimal here, and 2 behind the decimal here. If I want to get rid of those decimals, I need to multiply by the greatest number to do that. So if this is going to the hundredths place, I need to multiply by 100 on every single one of those numbers to get rid of the decimal. So what is 6/10 a times 100?
68.
60A. Plus, what's 18 and 6500ths times 100?
1,186.
Right, it just moves the decimal point to the end. And 22 and 8500ths times 100?
2,285.
2,285. Now you're back to our standard two-step equations. So now what?
Subtract 1,000.
You get 60A equals 420. Next,
Divide 60.
how many times does 6 go into 42?
7.
So 60 into 420 has to be 7 times. Sorry, I don't need those zeros on there. Just 7. Okay, so in the next one, how many numbers behind the decimal point? 3, 3, and
3.
so what are you going to multiply them all by? Multiply them all times 1,000 to get the decimal point to the end. Now what? Subtract 2,458. My handwriting's too squished, I can't even see what I wrote. What do we get when we subtract 5,125? Next, divide by 1,025. What do you get? Should just get 5. Any questions on multi-step equations? Okay, story problem. You need to build a rectangular pen in your backyard for your dog. One side of the pen is going to be against the house. All right, I'm already going to draw a picture. Here's my house. Here's my fenced-in pen. Two sides of the pen have a length of X feet. And the width will be 25 feet. What is the greatest length the pen can be if you have 63 feet of fencing? What is the greatest length of pen? What is the greatest length the pen can be if you have 63 feet of fencing? Well, if I only have 63 feet to use, something has to equal 63, right? Okay, what am I going to do to get to that 63 feet? What is our equation going to be? Isaac?
63 minus.
No, 63 is on the side by itself. How are we getting to the 63 from this picture?
2x plus 25.
Yep, 2x plus 25. Or could we say x plus 25 plus x? You could, or you could go right to the 2x. So I'm adding up all three sides of fencing to equal the total of 63 feet that we have. So now what? Subtract 25 feet off from the length. So 63 feet minus 25 feet for the width of the fence, rather. would give us what? I'm sorry? 38? Now what? X is going to equal? So I can go 19 feet by 25 feet. 19 feet out from the house, 25 feet wide, 19 feet out from the other side as well. Questions on that?